Hi all, today's topic is Laurent series for a problem 3. F of z is nothing but z divided by z minus 1 into z minus 3. So it is some condition is given, it's a different condition, okay. So when it is given like this, modulus of z only still now we have seen in the previous video. But now it is given z minus 1, what we have to do in this case? First I will find the partial fraction for this problem and separate the terms. So it is easy for applying a Laurent series. So partial fraction when I do it, so what is our question? Z divided by z minus 1 into z minus 3. It's a simple partial fraction, only two terms. So a divided by z minus 1 plus b divided by z minus 3. So take a LCM. So z is nothing but a into z minus 3 and b into z minus 1. So put only two terms, z equal to 3, what happened? And z equal to 1, what happened? Okay, so when I put z equal to 3 means a will be cancelled. So I will get my b solution. So b solution when I put, so z equal to 3 when I put, so 3 equal to 3 minus 2. So 2b. So b is nothing but 3 by 2. I'm getting b to be 3 by 2. Same b is it equal to 1 when I put 1 equal to a into 1. So minus 2. So a I will be getting minus 1 by 2. So I got the solution. Now both you substitute in the given question. So minus 1 by 2 into z minus 1 plus 3 by 2 into z plus minus 3 is the given question. So now in this question, write the new f of z. So what is our new f of z? So f of z is nothing but minus 1 by 2 into z minus 1, like this you write it, plus 3 by 2 into z minus 3. So this is our new. With respect to the condition given, I am going to expand it using a Lorentz. So what is the condition given in the question? 0 is less than modulus of z minus 1 is less than 2. So this z minus 1 I am going to take to some other variable u. Z minus 1 I am going to take to the some other variable u. So z is nothing but u plus 1. Replace it, instead of every z, replace it with the single variable u itself. So calculate everything. Finally, I will again replace it with respect to z. So that only I am going to convert it into u, find out the solution, again replace it with the same original question. So that if I do it, so what it happened? So this full question now changes to 0 is less than modulus of u is less than 2. So what is this from this? So it is nothing but this 0, it's not valid. So only this right hand side when I take it, it's nothing but modulus of u, this 2 when I take it by 2 is less than 1. Okay, so now this f of z, so this f of z fully I will convert it with respect to u so that it is easy for me. So now when I convert it, what happened? So now z minus 1 is u. So minus 1 by 2 as it is 1 by u. Correct? Z minus 1 is u. Plus 3 divided by 2. Z minus 3 what happened? So z minus 3 is nothing but z minus 3 it is nothing but. So z is u plus 1. So u plus 1 minus 3. So u what happened? U minus 2. Okay, u minus 2. So 1 divided by u minus 2. Okay. So this is our original now question. With respect to this, write the expansion. Okay. Then substitute finally. U is replaced by z minus 1. Replace it. It's easy. So that only I'm going to do in this. So when I write this no expansion, it's a single variable. So leave it as a single variable itself. This only I will write a expansion. Whether it is cancelled with this, we have to cross check it. So now minus 2u as it is, okay, plus 3 by 2. In this only I have to check with respect to this condition. Okay, modulus of u by 2 is less than 1, whether I have to write. I have to write it of this format, then I can expand it. So how can I write? By 2 I have to take it. So in this term 1 divided by u minus 2 can be written minus 2. If I take only, I can write 1 minus u by 2. Correct? So that only I am going to write minus 1 by 2 into 1 divided by 1 minus u by 2. So this can be written as a numerator. Next step I will write. Okay, so now minus 1 by 2u equal to minus 3 by 4 into this can be written in the numerator. So 1 minus u by 2 the whole power minus 1. Okay, this expansion you can write 1 minus x the whole power minus 1 is nothing but 2u minus 3 by 4 expansion. You know normal expansion or general format also you can write, no problem. Why I write it this format means I'm going to check whether it is cancelled with any previous term. Okay, this term and this term whether it cancel we have to check. Otherwise no need. Okay, so 1 minus so 1 minus x the whole power minus 1. It's nothing but summation over it is x power n is the format. No, so now it is 1 minus x. So it is summation over u by 2 the whole power n. Okay, so now I have written general format. So replace it with the original question. Instead of u we have taken to be z minus 1. Now z is our original question. So minus 1 by 2 into z minus 1 minus 3 by 4 into summation over. Okay, so now replace it z minus 1 divided by 2 the whole power n is our Laurent series expansion. It is valid for the given condition because according to our condition only it is valid. It's nothing but 0 is less than modulus of z minus 1 is less than 2. We have replaced the original question u is in terms of z minus 1. Okay, so this is only 1 minus x the whole power minus 1 is summation over x power 1. If it is some other question 1 plus x the whole power minus 1, the general format is summation over minus 1 the whole power n into x power n. Only the change minus 1 the whole power n into x power n. Only this you have to remember it for a general expansion. Or it is not wrong by doing instead of writing this as a general format, you can write the expansion form. I don't remember like the summation format. So in that case what you can do, you can write it like this way also. Z minus 1 as it is, minus 3 by 4 as it is. This you don't remember at all, summation. This you know the formula, 1 minus x the whole power minus 1, what is the formula? 1 plus x square. So that format you can write it. 1 plus according to z minus 1. So z minus 1 by 2 plus z minus 1 the whole squared divided by 2 the whole squared plus etc. Like this also you can write it. It's not wrong. Okay, any one general format or expansion format. This is the Laurent series expansion for this problem. Thank you.